Hello, I would like to demonstrate now Sital Tails Code Key technology for finding and maintaining bus 1553 bus problems. In order to demonstrate, what we are going to use is the Sital multi-combox system, which is a 1553 tester. We have to the tester we have a cable connected, a 1.8 meters cable, and at the end of the cable we have a connection with termination. And I hope you can see the termination here is a resistor of 120 ohms, which is a little more than the termination required for 1553, but it acts as a good termination. And we can see on the computer here the software that manages the tester. What we have here is the simulator, which creates 1553 frames. We have the monitor monitoring those frames, and we have a monitor for the tails, and we have a list of tails, one for each remote terminal that exists in 1553. What we can see now that the tails are currently 0 because the network is connected and well terminated. Now, for the first step, let's disconnect the termination. Now we have an open network that is connected through a 1.8 meters cable without any termination at the end. And as I said, this tester transmits and monitor the transmission, or actually it can monitor the reflections on the bus. And what we see here, very hard to see, that we see a very, very small tail with the number of 8, which means 8 nanoseconds tail of the message. These 8 nanoseconds correspond to the 1.8 meters cable that we have. What we are going to do now is to add another piece of cable, which will simply add some distance to the already existing cable and make it a little longer. By making this cable a little longer, and this cable has no termination at the end, simply open, what we are seeing is that the tail has changed a little bit. Again, very hard to see, but you can see that the tail is a little longer, and the number showing here is 16, which means 16 nanoseconds. 16 nanoseconds correspond to the almost 2 meters cable that we currently have. One more addition to the cable. Let's put some extender and another 1.8 meters cable. And what we would expect now, since we have now a longer cable that is not terminated, what we expect is to see a bigger reflection, or a longer reflection actually I should say, and you can actually see that the reflection has become longer, and the number here is 24, which means 24 nanoseconds, which is about what we should expect on 3 meters, or a little bit more than 3 meters. Now, as the last part, we will put back the termination to the network. However, we keep the unterminated part still intact, and what we expect to see is that even though we assume to have termination on the cable, which is a simulation for the rest of the network that is well terminated, still we maintain to see here the number 24 and the reflections, because the reflection is not should not end, because there is an additional unterminated cable here. In other words, what we have seen here is a tester that transmits 1553 data to a terminated network, and we see no reflections. When we transmit the same data to an unterminated network, then depending on the length of the cables, we can see the length of the termination with accordance to that. Obviously, in reality, it wouldn't be such nice zeros, but you will see reflections on several RTs. But once you freeze this situation, it should not change even when the aircraft does any kind of maneuvers or any changes in the data. And the other nice thing about it is that we don't actually need to transmit any special thing, but these are the standard 1553 messages. Obviously, we expect the same kind of things to work on a CAN bus, yet to be proved. Thank you very much.